Okay, it's time to get started. Thank you for joining today's panel entitled The Need for Distribution Automation and Power Grid Reliability. This virtual event will cover the importance of paying attention to the distribution segment of the power grid and the investments that need to be made to it, as well as the workforce behind it. Our panelists will discuss what can be done to enhance the skills of the workforce to meet this imminent need. Attendees will also be introduced to the career development program from IEEE entitled the IEEE Academy on Smart Grid Distribution Automation, developed to provide the fundamentals of the existing power distribution system and the advanced functionalities in distribution automation, period. This panel will be moderated by Satish Saini. My name is Phyllis Caputo, Program Manager for IEEE Smart Grid, and I will be your event specialist for this session. Quick introduction on IEEE. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Before we begin the panel, please note a few housekeeping items. At the bottom of your screen are engagement tools that you can use. All tools are resizable and movable, so feel free to move them around to make the most of your space. Note that we recommend the use of a wired internet connection to access today's presentation and closing any background programs. There is no dial-in number for this event. Please make sure your computer speakers and headsets are turned on and the volume is up so you can hear our presenters. So if you have any questions for today's presenters, you can submit them through the Q&A widget on your screen or click the purple Q&A icon on the bottom of your screen. We will answer as many questions as time allows. Please note we're collecting the questions and plan on creating a document in the future to get to any questions that we might have missed due to time constraints. Finally, the on-demand link for today's event will be emailed to all registrants approximately 2 hours after today's session. And if you would like to tweet about this event, please use the hashtags IEEE Learn and IEEE Smart Grid. At this time, I'd like to hand the panel over to our moderator, Satish Saini.
Thank you, Phyllis. Thank you so much. And good morning, guys, to all our attendees from North America. And good afternoon, good evening to all others across the globe. Thanks for your time and thanks for joining this event. We have an exciting panel and we would like to discuss the need of distribution automation and power grid reliability. So as we all know that the economy, the whole society, our industry, our commercial organizations, even our residences, everything is like dependent on electricity. Even few minutes of power outage impacts us very heavily. So it might be weather-related events, it might be human error or accidents or equipment failure or technical issues, the grid operations and the reliability is impacted. So for decades, we have been putting a lot of efforts in adding generation, whether it's renewable or traditional, having more the things on the transmission system, all of our utilities, industry, they are doing a lot of things to enhance the resources on the generation and transmission system as well. But somehow seeing that we need to focus more on the last leg of our power delivery, which is our distribution system. So today we will discuss how our distribution system is being impacted by all these outages and events, and how the new automation technologies are helping to enhance the overall efficiency of the system as well as the power reliability to our customers. So today we will have our three distinguished professional panelists we have with us from a diverse background from utilities, industry, and academia. So I would like to introduce first our panelist from academia side, Harpreet Randhawa. So Harpreet holds a master's degree in electrical engineering and is a registered professional engineer. She is a professor in Conestoga College in Ontario, Canada, and has about 15 years of teaching experience at various engineering and technology institutes across the globe. She has a few years in industry as well in designing, building, and troubleshooting various electrical systems. So she has a pretty good, like a diverse background, but major focus on teaching. Harpreet has a strong passion for energy and power system education, training, and skills development as per the latest technologies and trends. So she's with us today with all her thoughts and experience in the sector as per the needs of the industry and also for the career development of our younger generation. So welcome, Harpreet.
Thank you.
Our second panelist, thanks. Our second panelist is Somdat, who is the Director of EcoSmart Solutions, an industry providing services in various areas of energy and power system, especially transmission and distribution, but including renewable energy sources as well. So he has around 22 years of experience working with public sector undertakings with various other industry by managing, designing, deployment, and implementation of projects related to power T&D, transmission and distribution, renewable energy, and especially his expertise and his work relates to the SCADA system, distribution management system, which is DMS, outage management system, IoT, AMR, smart metering, MDS, MDM, smart grid, substation and distribution automation. So he has a diverse industry background in various technologies and solutions in the current, like a modern world. He has also been involved with the World Bank projects with numerous utilities in deployment and implementation of various automation programs. So he brings this vast experience today with us in the power industry to share some of his views with us. Welcome, Somdat.
Thank you, Sanjeev.
And our third distinguished panelist is James McQueen. So James is a registered professional electrical engineer and having masters in business administration too. He's working as a distribution planning engineer with the PPL Electrical Utilities in Allentown, which is in the state of Pennsylvania, USA. He has more than 15 years working with utilities in North America with extensive experience on DERs, which is distributed energy sources, transmission and distribution system, planning, design, commissioning, inspection, testing, and many more. So he has been supporting various initiatives on electrification, BESS, which is like storage technologies, installation standards, and GIS system upgrades, and has been involved in various solar projects with the C&I facilities, and also developing proposals for funding and other with the government agencies and other funding entities. So he also has been supporting large customer projects on various vehicle to grid integrity as well. So a lot of things James has with us. So welcome, James. Myself, Satish Sani. Thanks. So myself, Satish Sani, is the moderator of this event. I'm an electrical engineer with around 35 years in experience in the power industry, mostly with the utilities, operations and management, DER integration, and distribution grid modernization. I'm also the chair of IEEE Smart Grid Technical Activities Committee, and also the chair of IEEE Education Committee in Toronto section. So first thing, welcome all the attendees and welcome all the panelists and welcome the team of IEEE. So this event is today is organized by IEEE Academy on Smart Grid and IEEE Educational Activities. So other than our panelists, we have a team of experts and staff from IEEE helping and managing this overall event. So welcome all. So the session today will have around, I will say, a few segments, which I will say around 3 segments, and each addressing different areas and issues related to the power distribution system and automation. So as Phyllis has mentioned, so I will say hold on your questions to later Q&A session or try to put into the system or in the Q&A section in your, I think, wizard you have. And then we'll try to answer all your questions once we are done with our discussion. So here we go for this exciting discussion on a few of the burning issues impacting all of us. So I will request to go to my first slide, please. Amy, do we see the first slide? Okay, I think there might be some system issues. So can somebody help us with the first slide?
I think it is there on the right side of the screen, Sanjeev.
But you can see this, right?
Yes.
Yeah, we can see it on the right side of the screen.
So that's fine. So that's why I wanted to make sure that we are able to see this slide. So what happens is that in the first slide, we see there how these weather impacts our system, power system as a whole. So we see California summer heat wave in September 22, and the Texas winter freeze in 2021, the Hurricane Ian in September 22, Hurricane Fiona. So means all these events have impacted our power system a lot. Like sometimes 50% of our customers are out of power, or something like millions of customers, like 2.6 million, or like the whole state of California, we have been seeing the impacts of this weather-related events on our power grid. And the disturbing factor, if you see that in the report on White House in the USA in 2013, so they have been mentioned that the weather-related blackouts cost the US economy, just the US economy, an annual average of $18 billion to $33 billion. So I mean, that's huge. It's very, very huge. And even 2012, the superstorm Sandy, the cost estimate range from $27 billion to $52 billion. So it means there has been huge impact by these weather-related events on the power grid, and how many millions, billions of customers have been impacted, and billions of dollars we are losing in the economy to all these weather events. So my first question will go to James, who's from the utility side. So James, what do you think, like with this current scenario on weather events, their severity, their impacts on the power grid, how do you see the utilities are preparing to face these events to maintain the power system reliability?
As adverse weather patterns continue to increase in frequency, utilities begin preparing for these events in advance of their occurrence. They utilize a number of internal and external sources to predict and implement pre-event responses. Mostly, they develop and continue to refine outage prediction models, and then they use inputs from a number of data sources from multiple meteorological sources, and then they take those and they start to complete analysis. In consideration of a distributed automation response, utilities have been able to leverage advancements in devices, telemetry, and control to better react to all outage events, storm and non-storm related. In addition to the advancements in the devices and the increase in data available, there have also been great advancements in the associated control systems for distribution system operations, from SCADA systems to ADMS, and including DERMS and other things.
Yeah.
So in consideration of these advancements in device capabilities, as well as control systems, this has allowed utilities to implement a number of scenarios and attempts to reduce the number of customers impacted by singular events. These scenarios include, and are not limited to, electronic versus hydraulic protective devices, as well as restoration transfer schemes between intertide feeders and substations. In considering the electronic reclosers versus hydraulic protective devices, the introduction of these devices has allowed reclosing devices to implement new approaches to protection settings, which are able to be implemented versus those that were available within hydraulic devices. The flexibility of these settings enables unique settings to be applied as a feeder configuration dictates, and strive to continue to improve customer reliability. In addition to the greater number of settings that are available within these electronic protective devices, advancements in telemetry have increased the ability to monitor each device's status and provide additional data on the performance of the feeder at that specific point.
Okay.
During weather or system events, the system operations teams are able to identify large outages due to the protective device operation and monitor the impact of any upstream telemetry device throughout the outage period. The implementation of smart meters and AMI systems further increases the refinement of the outage notification. As the majority of this data is stored in an archive, detailed planning and future storm modeling is capable based on the device operating characteristics throughout the event. And with the implementation of the control to these devices, the availability of additional capabilities further increase as devices are able to be operated remotely through system operations and control. And this aids in improving system restoration, particularly during periods of cold load pickup, by way of sectionalizing portions of the feeder and closing devices as required.
Oh, okay. So it seems that there are more on these like telecommunication facilities we are using to remotely monitor and monitor the equipment and devices on a real-time basis, right?
Correct. The more the more telemetry devices we have deployed in the field, the better we're able to monitor and control and understand how the distribution system is operating at that time, but also leveraging that data looking back to be able to predict and forecast how things will operate in the future.
And can you elaborate more on these automatic transfer and restoration schemes being utilized by the utilities?
So as we further expand the capabilities of telemetry devices and the control systems that are associated, it's possible to utilize more advanced functions on both electronic reclosing devices and the associated control systems. And through that, we're able to develop automatic transfer or restoration schemes. These schemes rely on multiple compatible devices located on intertie feeders to be able to transfer customers between devices as situations dictate. As a transfer scheme relies on the ability of either feeder to supply the section of intertied of that section of the intertied feeder during an outage. The addition of more devices within a given scheme increases the flexibility of the scheme, as well as increases the sectionalization capabilities to limit the number of customers that may be impacted by an outage within the section outside of the scheme.
Okay, got it. So it seems that what you're saying, James, is that I think it's a real interesting scenario you have put there, how utilities are getting ready and how they are using all these telemetry and other technologies. So it's like more on the restoration effort. So it means that if the weather events happen, so definitely they will impact the grid. So there will be an outage, but the utilities are getting ready because we can't avoid the weather. So we can't control the weather for now. What we can do is that we can do our restoration efforts, which we call it resiliency. So it means we are making our system a bit more resilient, which can sustain these severe weather impacts and quickly restore the power to all our customers through automatic transfer schemes and restoration schemes. So as you mentioned, yes, we have FLIZR, we have FIDR, and we have ADMS systems. So it means utilities are getting ready to face the future with all these weather-related events. So that's interesting to see that, yes, we are using all these schemes and all these technologies to restore the power as quickly as possible and bring the reliability indices up. So that's interesting to know. So with James has mentioned all these technologies and solutions, so it seems that industry is also getting ready because ultimately utilities are using all the devices, technology solutions from the industry. So how do you think industry is helping the utilities and even preparing itself for the future to meet this challenge?
Good morning, everyone, especially our attendees. And I would like to present it from the utility industry side. And when we say industry side, first question which industry faces is how the distribution automation is different from any other SCADA which is being used from the many decades in the transmission and generation. So the utility answer is yes. It's a big difference from the conventional SCADA to the distribution automation system, which is being the need of the hour by the utility. And if we have to define that change, I will define it in the one sentence, that we have to move from a predefined supervisory SCADA controlled operations to face the unexpected. Like Mr. Sanjay, you also mentioned that weather is not in our control.
Yeah.
So, and the fault in the distribution system, which is much more larger compared to a transmission lines or the transmission substations, the number of nodes are in the quantum of the millions. So the chances of getting a fault is quite high in the distribution system, and we have to be ready to face that system failure. We can't avoid that, but we have to be ready, and devices supposed to be much more smart in terms of helping the utility to restore the supply within, say, within few minutes at least, to the maximum possible number of the consumers.
So you think that industry is getting ready with all these products and solutions, right?
Yeah. If you see the last 1 decade, the many big projects are being deployed for the distribution automation by different utilities, and the industry has introduced many path-breaking technologies in the field of the distribution automation. And I will say the introduction of the IoT and the artificial intelligence in the field of the electrical automation has helped the industry to achieve these goals to a large extent. If we see last 1 decade, the industry has moved from the conventional SCADA system to the ADMS, which is Advanced Distribution Management System. And it is having much more advanced features. As my friend from the utility mentioned, that it is having the features like self-healing grid, where we can restore the grid automatically without any human intervention. It has the facility like Flazel, which is fault localization, isolation, and system restoration functionalities. It has the outage management system, which, with the help of which we can identify the consumers and inform them about the failure of the system and the expected time of the revival of the system, so that our consumers also get involved in the system and they are well informed about what is happening around.
Okay.
So they are well prepared about it. So you can, I will quote an example. If we have a ADMS system which is tightly integrated with our weather forecasting system, so in case of a chance of a weather change or a situation which can cause the power failure, we have a facility to inform our customers well in advance when the event is likely to happen, and then what may be the extent of the failure of the power supply to the consumers. So that helps a lot for the planning part, as well as avoiding the system failures, because we are well prepared about it. So that was from the software side. When we move to the electrical side of it, we will talk about the smart devices. So we have the smart devices like auto reclosures, which can detect the fault and try to restore the system. We have the sectionalizers, all the fault isolators, which can disconnect the faulty section. We have the smart meters, which is very much important to have the information about power flows in the system. And we have the smart RTUs, which is completely different than the conventional RTUs we supposed to have in the past, which the devices can itself take a decision based on the local conditions, even without intervention of the SCADA system from the utility side, which may occur in the worst environmental conditions like failure of the communication system. So device can locally take an intelligent decision and try to restore the supply as much as possible.
Okay.
So industry has advanced in both from the software side as well as the electrical devices side in last 1 decade or so.
Okay. So Sundar, what you are saying here is, so what I see here is like traditionally when we started our career like decades ago, not decades, like maybe 30 years ago. So at that time, the power system was just like electrical lines, electrical transformers, substations, breakers, and all that. But not seeing that with all these implementation of distribution automation, SCADA system, or whatever we call it. So we have a lot of other supporting services like technology, including like IT, telecommunication, software, computer hardware. So now we see the power system like a mix of like a different technology with different platforms. So I think that's very interesting to know. I think these are the technologies which are helping us.
Mr. you are absolutely right. Like if you see the power system which was there in 20 years or so before, it was mainly aiming to give the power supply to the consumer. But when we talk the power system at the present, at the modern stage, we are not talking about the power supply. We are talking about a reliable and quality power supply.
Exactly, that's right.
So, so a failure of few minutes now disturb the life, because the complete system, complete human life becomes dependent on the electricity, number one. Second, the more and more electronic devices we have in our life, the quality of power supply becomes even more important. Fluctuations in the voltages, frequencies, it's not that much tolerable now, which was there in 2 decades before.
Yeah, because
So
at the
that way,
consumer level, sorry, go ahead.
yeah, and for our thing, like if you see, say 20, 25 years back, the electrical system was supposed to be isolated system. Nowadays, when we say electrical system, it's not just electrical, it's a combined system of electrical, communication, and IT systems, which
Absolutely.
have a huge data flow, real-time data flows, which is backed by latest technology development in the field of communication, which has helped the deployment of these systems a lot.
Right. So I think that's pretty interesting that, so this means this sector is also creating more jobs in, not even just in the power system or electrical system, it's also like enhancing jobs in the IT, communication, or software or hardware. So that's pretty interesting to know. So I mean, the industry is creating more jobs in various segments of supporting services as well when we talk about the power system. So I think from that perspective, so I will go next to Harpreet. So Harpreet, when we see that utilities and industry, they are putting all these efforts, new technologies are being developed, so new products are coming in. So with all these crises on the weather events, because in parallel, the weather events are also increasing. Like we are having a lot of these bigger impacts. So how do you think that we will be able to meet these expectations of the economy and the society regarding the reliability of power in future? Harpreet?
That's true. Like as Somdat and James has discussed, that the utilities and industry, they are getting ready, and they say that they can achieve the target to reduce, to go to the net zero carbonization by 2035 or 2050. But as per the study from IPCC, that is Intergovernmental Panel for Climate Change, they says that utilities and industry, they are not on the right track to achieve the target within the time frame, within the given time frame that we have set. So as per the IPCC, they says like every decade there is a temperature rise of 0.2 degrees Celsius. And we are already, we have set to temperature of, we have reached the temperature, global surface temperature of 1 degree Celsius by now. And we have set the target that we should make sure that the temperature, global surface temperature should not go above 1.5 degrees Celsius. And if this temperature goes above 1.5 degrees Celsius, the earth it will be very hard to live on the earth, because the heat waves will increase, there will be strong storms, and these factors will not make the earth as like green to live on this area. So I think there is an urgent need to make sure that we do not reach that global global warming level, and we make sure that we are set at below 1.5 degrees Celsius. So many countries.
Sorry, as you are saying that, then it will be scary that you say that in the coming years, if this thing goes like this, we will not be able to live on this earth. So that's very scary.
I know it is scary. And like many Western countries, they claim that by 2035, they will reach the net zero carbon level, and there will be decarbonization, and globally by 2050 we should reach that target. So that is our claim, and there is a need to reach that target, otherwise we will go above 1.5 degrees Celsius. So that is the challenge now.
So how this is impacting, and what's the role of electricity sector in this?
Yes, Satish, you are right. Like there is a role of electricity, because as per the report, IPCC report, it says that 40% of emissions are coming from electricity sector. And you know what? It's not like the electricity sector need to set the target of net zero carbon emissions, because some sectors, some other sectors, they are dependent upon electricity sector. So let's suppose electricity sector is not able to achieve the net zero carbon emission target. The other sectors, they can never reach that. So for other sectors to achieve that net zero, electricity sector has to achieve that target. So now to achieve this target, there is a high urgent need of a high electrification pathway, like use of more renewable energy sources, setting up more projects with wind power, solar power, and energy storage devices, so that we can achieve that target of net zero carbon emission. And since the the conventional grid was using power from other sources like the conventional power sources. Now there's a need to upgrade the grid on the distribution sector so that they are ready to receive or accept the data, accept the energy from these renewable energy sources. And there's a need for modernization of the grid. And we know that our industries and utilities, they are developing new solutions or products to upgrade the grid.
Okay. So what you're saying is that I think that's a correct message that whatever efforts we are putting on the generation side, so adding just renewable energy sources will not be the overall solution. Yeah. So we need to actually address the overall power grid, which is including the transmission high voltage system as well as the distribution segment. So we need to enhance the efficiency and productivity of these sectors as well. So I think that's a pretty good message. So thanks, Harpreet. So I think with this, we see that what are the impacts of the weather on the grid and how we are, utilities and industry are getting ready for these things. So now we go to our second segment. So can we go to the second slide, please? So do we see this?
Yes, it is visible.
Okay, perfect. So these are the few of the things like from infrastructure report in the United States. So they say that even though the distribution system, there is a lot of like failure events on the distribution system of the power grid. And the distribution system accounts for more than 90% of the electrical service interruptions. So it means definitely somehow this system seems to be a little bit have been neglected in the past. Certain things we cannot avoid. Again, as I mentioned, that distribution segment is more scattered. It's more geographical scattered. So yeah, that's why maybe this is like a huge sector. So that's why 90% of the interruptions are on the distribution segment. And also, as we see from the infrastructure report, that a lot of investments have been made, like 15 billion to 21 billion between 5 years on the transmission, but only the distribution system was like having like a very less investment as compared to the transmission system. Like they grow only 54% in the past 2 decades. So means that the transmission investment was doubled in 5 years, but distribution was like only 50% in 2 decades. It means somehow the system has been neglected. So, and we also see that the distribution automation market is like it's $1 billion market for the near future, especially in the next 5 to 20 years. So what we see from this is that the distribution sector being neglected, and we need to focus more on this. So again, I will go to some of that again from the industry. So keeping in view the impacts of the distribution system being so scattered and having the larger number of aging equipment, because now we see that all over like a field, like wires or the poles or the transformers or breakers. So all the equipment are aging, like they are like 50, 60 years old. And this is like a widely scattered. And to monitor all these things like remotely and on the real-time basis, I think it's a big challenge. So what are some few types of distribution automation technologies from that, and what are the products available to enhance the reliability, especially for this scattered system?
Yeah, as I said earlier, and Mr. Sani, you also mentioned that the number of faults which are being introduced into the system are mostly from the distribution side. And the reason lies behind that. When we talk about the distribution system, we are talking about a system having millions of the devices interconnected. It's not a small system like a generation system which has few lines, but just for example, if we see a 400 kV transmission lines or a say 500-600 megawatt generation plant, that generation which is being done by one plant or one transmission line, it will be serving to say 1 million customers, having say thousands of the distribution transformers, hundreds of the distribution nodes. So a single failure from the network side impact to the distribution network in a large way. Every time if we see the chances of that system getting hit by the faults in the distribution network is very high. The reason behind why the distribution sector was neglected lies because of the reason in itself that the distribution devices are scattered geographically. It's not that you have to mention, you have to monitor some devices which are concentrated at a point. they're scattered geographically, and
Yep.
there was a lack of the communication systems if we go say 10 to 15 years back. But if we see the growth or the developments which has occurred in the communication network system in last 10 years, we have moved from 2G systems to the 6G now, being rolled out in many parts of the world. Also the other technologies in the communication, which is the radio frequencies, Zigbee, kind of the development has helped the implementation of the distribution automation system at a large scale now in last 5 to 6 years. And we see that utilities are adopting the distribution automation system at a large as of now. When we talk about various systems which are available for the distribution automation, we can talk about starting from the software side. So the development which the industry has done in last 10 years, it's not about having a independent systems of the distribution management. The development was to have an integrated solution approach to the utilities. So now we have a solution where we have the distribution automation system in one hand and the other IT solutions, being a AMI or AMR, which is metering the energy flows, being the GIS solutions, being the other IT systems. They are all clubbed together to deliver a system which can fulfill the needs of the utilities for the effective management of the complete distribution network, as well as the consumer base.
Got it.
So we have a much better and reliable system now, which not only can help the utility to manage its operations, but also give them the predictions and the forecast to have the pre-caution approach to the upcoming events.
Okay.
So they can now forecast their future demands. They can forecast the future peak demands of the system so that they can plan accordingly. They can also predict what will be their demand in next 2 years, 3 years, or 5 years, so that they can plan accordingly. Also, if you see the change in the power system which has occurred in last few years, is that earlier we were just stepping like to meet the distribution needs, the power demand needs, we were increasing the generation. But now, as the ma'am Randava clearly said, that that's not the solution, because more and more power we generate, more and more carbon and the environmental impact we have on the Earth environment. Right. So we have to stop somewhere in terms of the generation. So now the demand, we have a need of hour that we have to manage our demand. So we have a solution in the power distribution automation system, which we call as the demand side management, DSM.
Absolutely.
In which we control the non-essential demands in case of the peak and the crisis which, like you had mentioned in your initial words also, that there was a crisis of the having a very peak demand which may have caused the grid failure during the heat waves. So that kind of scenarios can be, I can say, avoided by use of the such IT integrated system.
Got it. So I mean, there's also like a holistic approach. You are saying that.
Yeah. Also,
so
we
you
have
see
a
that
lot
like
of
there's
development in terms of the. Yeah, please.
Yeah. Go ahead.
So we have a lot of development in terms of the second side of the system, which is the electrical system. So now we have the more reliable and the more secure systems, like we have the electrical devices, which say solid insulated devices, which is not impacted by the weather change. We have the IP56 switch gears, which can be even submerged in the water so that they are not impacted by the heavy rains or such kind of the systems. So those kind of systems are being introduced by the industry. Also, we have more intelligent field devices in terms of the RTUs, FRTUs, or the IEDs, which can communicate much faster, which can use the modern communication media to give the better results.
Got it.
And on top of that, we are moving ahead to have the systems more cyber secure, which is the need of ours. Like
cybersecurity is a big issue these days.
With the we are dealing with a big pile of the data. So we require the solutions which are cyber secure. So the industry is working very hard to make the systems reliable and very secure in terms of the cyber security.
Got it. So I think you have brought a very good question. Like cybersecurity is a big issue when we're managing all this data from remotely as well as on real-time basis. So, but still we see that there are a lot of advantages, the benefits we are getting from these technologies. So I will go to James, like, what do you think, like some of the successful case studies by utilities on these distribution automation technologies that we are adopting? James?
As we previously discussed, and both of our other panelists have described, as distributed automation continues to advance, the ability to continue to improve customer experience, both by limiting outages and stable voltage and supply, also continues to improve. The ability to increase the sectionalization of impacted feeders greatly improves the reliability to all customers. Utilizing the telemetry devices for fault location greatly improves the ability to direct field personnel towards a fault location, and this can potentially significantly reduce the time required to identify the location of an outage, reducing the total outage and restoration time. Additionally, the implementation of smart meter data is enabling a further understanding of the number of customers impacted, as well as the total duration of the outage itself. As we've mentioned previously, the increase in the number of deployed, telemetered, and controlled devices within a distribution system provides a wealth of information pertaining to the operation of numerous sections of the distribution system. While the number of data points can seem overwhelming at first, the ability to examine areas in details further improves the planning and forecasting, as we just discussed. As we're all witnessing within the distribution system, it's currently undergoing a significant change with the new types of load being added, as well as increases in distributed generation adoption. With these changes in loading and generation profiles within feeders and substation, the increase in telemetry devices, both protection and non-protection, are enabling utilities to examine and study these areas to address and prepare for today and for the future. From a protection perspective, these changes in feeder loading profiles require additional study to determine settings, parameters, and things that need to be implemented to ensure the safe operation of the distribution system. This will be especially evident as we move towards as utilities move towards implementing a greater number of microgrids.
Yeah, you're right. I think there's a microgrid as well as, and with the storage technologies and all that, we're also moving to nanogrids, like very small grids, even at our residential premises or even commercial. So I think that's a very good point that, yes, there are a lot of changes happening and some lot of good case studies for the future. So, but again, I'm a little bit concerned about, maybe Herbert, I will come back to you a little bit later on this, because there are a lot of things to be discussed on the academia side. Because with all these technologies happening, like communication, telecommunication, IT, computerization solutions, hardware, software in the power system. So I will come back to you a little bit later, like how institutes are working on this and what are the challenges for that. But before that, I will come to you in the next part. But let's go to our third slide, which is our third segment. So is everybody able to see it?
Yes.
Okay. So now we see that as per the U.S. Department of Energy, so they did a couple of smart grid programs on the distribution grid. They spent some money and they found the results that, yes, there's a lot of good improvements. Even they were able to reduce power outages by 53%, and they reduced the number of affected customers by as much as 55%. So means there have been good, I would say, case studies or the best case practices by the utilities and the industry. But we also see the challenges. It means working on this huge system, as we talked a number of times, like scattered system, widely scattered. So there are challenges with the utilities, industry, and even education and training. So this is another segment which we found, like as per a study by Human Capital Institute, like many Americans, or not even American, at global level, we see that like jobs are available, but there's a gap, and this gap is costing the U.S. economy as much as like $975 billion over the next 10 years. Because there are another reports that jobs are available, but skill sets is missing. So means our workforce, or our younger generation, or our graduates, they are not having the right skills which are needed in the industry. But we'll come back to you, Harpreet, a little bit later on this. But I will go to our panelists again. James, again, I will a little bit put you in the spot that with the development of these technology and all that on the distribution segment and opportunity in the distribution automation. So what do you think about the future market of this distribution automation and some of the challenges in this deployment?
I think as the distribution system continues to evolve, utilities are going to need more data to optimize operations of the distribution system going forward. Mm-hmm. And these sources can range from traditional devices such as reclosers, regulators, capacitors, and those sort of things, and also the integration of some more non-traditional devices, such as ability to monitor temperature, opacity for solar, anemometers for wind, mm-hmm. and things like that. And that's all to help and aid in the understanding of the current trends mm-hmm. for DER management. As we spoke previously, as our distribution system continues to shift and change, the need to understand what distributed generation is doing and how it's impacting the distribution system today is going to help us plan for the future forecasting of how it's all going to operate. Mm-hmm. With the input from all of these devices and the historical data, we'll be able to make more informed decisions pertaining to the operations today, as well as for tomorrow. Mm-hmm. And utilizing all of these new data sets and points is going to drive new types of analysis to be performed, both on the feeder and substation, from profiling the system today, as well as how we're going to need to modify and make changes towards our protection for tomorrow. And there's a number of these data sources. Sorry, mm-hmm. Go ahead.
No, I'm just thinking like from these perspectives. So do you think that there's a need of a separate distribution system operator like DSO in line with the TSO what we have currently?
Yeah, I think as the distribution system continues to increase in complexity, we're going mm-hmm. to need to have more subject matter experts in all facets of distribution engineering, both on the operation side and, mm-hmm. and system control side, as well as
That's right.
in the field and planning and mm-hmm.
Protection.
It seems to be that we're in an ever-evolving system, and we need to understand what the needs of tomorrow are going to be, so that we can prepare for it today.
Perfect. So I think the question again will go to Harpreet the later segment, that when you're talking about subject matter experts and all these specializations, so then again the things go to education and training. But again, Harpreet, I will give all the questions to you just in the next, just after the Somdat. So Somdat, okay. As James has mentioned these things like for the future, and what do you think like industry is making efforts to meet the needs of the future? Somdat?
I'm audible?
Yeah. Yes, you're audible.
Okay.
So just try to finish in 5 minutes, because we're just running out of time and we need to have a Q&A with the audience as well.
Okay. When we say, I was disconnected for, I think, a while. Can you just repeat what was the question you had?
So as we see, like we move from utilities, that utilities are doing a lot of things, distributed system operations, subject matter experts, specialization in operations and control systems. So utilities are trying to get ready for the future. So how do you think the industry is getting ready for the future to meet this challenge? Just to try to be a little brief.
If you see, yeah, if you see from the industry point of view, the industry has transformed from a very equipment-wise approach to give a solution-wise approach to the utility. That is one. But when we talk about, especially about the distribution segment, we have the issues which is being faced by the industry as such that the implementation of the distribution automation is being done on the already installed systems, which belongs to many different generations. Like we have the electrical devices which was installed in last 10 years, maybe last 15, 20 years or 30 years even. So we have to have a system which is capable of integrating all that kind of the legacy system into one solution and provide the complete working environment to the utilities. So industries are working for that. But as you also mentioned correctly, that still there is a gap in terms of the educational background available to the new technology.
New generation or the new graduates.
In last 5-6 years, yeah. So that is one challenge that the last 10 years, the technology has changed in a much faster way, faster pace, which is supposed to happen in last 100 years. We have seen much more technology change in last 10 years, which has happened. So that kind of technology change and the many technology is getting absolute or in a life cycle of 5-6 years even. So we are facing a very big challenge to have the right skill set with the engineers to face this kind of the fast changing technologies.
That's right. So Somnath, I think definitely you have brought another good point, which is already aligning with our thought and our next question to Harpreet. So means, Harpreet, when I brought these things also earlier as well. So James brought this up like specializations. Somnath also brought this like technology changes very fast in the last 10-15 years. So how do you think like academia or education institutes are getting ready, and what are the gaps, and how they are getting all these resources to train the workforce?
Yes, I know like there are a lot of resources available on new technology or renewable energy sources or microgrid or various products that industry has developed. But the challenge here is like our colleges or universities, we don't have that all kind of new technology resources available. As the reason behind this is like, as you mentioned, we know that technology is, I think, changing every second day. To change the curriculum, it is very hard. We cannot change the curriculum at the same pace as the technology is changing. So that is the biggest challenge we are having. Like there is a long process to change a curriculum within a college or an university system. So there are challenges on that. And if let's suppose we are teaching today's current technology, maybe after 3 years, we will change our curriculum again. But in between, there is a lot of changes. And now due to this, there is a gap between the skill set of the industry needs and the curriculum. So due to that, I myself can experience that our students, they are not ready for the jobs, and even the graduate students, if I talk to them, they are not confident enough for the jobs because of the gap, because of this gap. And also on other side, the workforce is aging and retiring, and we have to prepare our future workforce who are currently in schools and in colleges. So we need to make sure that there should be something that can reduce this gap, and we prepare the workforce for the new technology that is developed by the industry and that is applied in the utilities. The thing is, like, if the products are there, technology is there, but if the workforce is not ready to use, then there is no meaning. So there is a need to reduce the gap.
Okay. So what it means you think that, yes, technology changing very fast for sure. Yeah. But colleges or the institute, they don't have the required resources or the plans to meet those needs, right?
Yes.
So that's a bit of, then how do you think, like, what else we can do to fill this gap? Is there anything else we can do?
I think like the organizations like IEEE, they should develop some courses, short courses, just so that our new graduates or even the working professionals, they can upgrade or brush up their skills so that they are prepared to use this products with new technology. They can update their skills. So there should be some short courses from some organizations like IEEE to reduce the gap, and this way I think we can meet the industry needs.
Okay, got it. So I think that's a good point that yes, because institutes cannot change the curriculum every time, and it's a very lengthy process, and they might not have the resources as well. So it means the role of professional bodies from outside is the big thing, that we can help the younger generation, new graduates, and even the students, and even the working professionals with some short courses as per the latest industry trends and technologies. I think that's a pretty good point. So I think just to conclude that we found that to meet the future expectations of the system, so number one is that we need to focus more on the last segment of this grid, which is the distribution system. And new technologies like distribution automation, like they are bringing a lot of good value to this overall power system reliability. And another bigger challenge which we found here, that skill set gap. So it means industry, the utilities, and the academia, we all need to work together to fill this gap, how we can enhance the knowledge of the younger workforce, younger generation, the students, and even the faculty, like what is happening in the technology, and how we can bring that value to the academia side with our resources availability, because institute will not be able to do all these changes like with the technology so fast as technology is changing. So we need to do something, like I think that's a good point, Harpreet, that yes, some organization like IEEE or even others, so we can have some short courses which are based on the real industry practices, real technologies happening in the field, and that's how we can fill that gap, and we can train our new workforce. I think that's pretty much. And another thing we found is that, as Somdat and James both have mentioned, that we need to have a holistic approach with the utilities as well as the industry, that not to just do a band-aid solution to the problems in the system, but have some holistic or comprehensive customized approach for utility problems, and how we can fix this reliability issue with the whole system. I think that's a pretty, I will say, the concluding point we got from all this discussion. So I think before we take another time, so let's go for the question and answer session. So let's see some questions from the audience. What do we have? So yes, so thanks, Phyllis, for filling in and getting the questions from the audience. So first question is that, can you interface grid reliability devices with the meteorological devices in order to try to anticipate outages and the load? I think Somdat or James, I think we both have mentioned something that yes, so we can give pre-warning to the customer. So I think it was Somdat from the industry. So Somdat, can you answer this question? That
yes, as I mentioned that now the industry is focusing on to give utilities a comprehensive integrated solution, and the ADMS functions are integrated to the weather forecasting system as well as the GIS system. So we cannot only find out the weather issues linked with our electrical systems, but we can also forecast which area or which consumers will be affected, so that the consumers can be pre-warned about all these changes which may happen.
Okay. So means these two things can be like
solutions are
so we can interface these devices with the system.
Integrated.
Okay.
Yes, absolutely, yes.
Hopefully we answer this question well. And the next question is, you mentioned something regarding self-healing, and we also mentioned something regarding FLIZR. So I think, can we say that these are like both correlated, or these are different? So how can we explain this? Self-healing and FLIZR. So that's the second question.
I will come to, So if you see, there's the two almost similar technologies, self-healing grids and the FLIZR. Self-healing grids are more important when we have the supply side failures. If we have a failure of one source, the system should be capable enough to isolate from that source and supply from some other available source or available resources. Self-healing grid also get integrated with the microgrid solution, so that in case of the complete failure, still we have some sort of the supply available to the consumers from the local available sources like solar or the battery storage system.
Okay.
As well as, but on the other side, when we say pleasure, it's more important to restore the system in case of a fault or in the particular section of the distribution network. So if we have, say, we are supplying to, say, 100 consumers from a particular portion of the distribution system, and in case of a failure, we will try to restore as many consumers as possible with the help of the pleasure technology. The technology will help to identify the faulty section, isolate it, and the restore rest of the system. So that is the major difference between two.
Okay, thanks on that. And the next question is, I think this might go to James. So James, there's a question that when we say that a lot of scattered equipment devices, millions, billions of devices along the distribution system, how we think that utilities or the entities will be ready with such a huge funding for the investment or to enhance these products and technologies. So how do you think like the funding will be impacting these initiatives?
It's an interesting position in that depending on how the utility is constructed, whether it's a government entity or a private entity, determines how the funding structure may work. Fortunately, there's been significant funding available from the Department of Energy to help facilitate some of these advancements. But others may occur just through the natural replacement of existing equipment and replacing it with the newest technology that's available. As we've spoken before on the requirement of networking and whether it's radios or fiber or other types of networks, those are probably some of the large costs up front to help support the advancement of telemetry and control throughout the distribution system. And those are probably some of the larger challenges that utilities are facing in trying to establish networks throughout from the start of the feeder to the end.
Yeah. So seeing that what we are trying to answer this question is that we need to have some prioritization on these implementation of the technology, because of course we need a lot of huge investment to do these automation technologies. But with the need of this huge investment, we need to prioritize our programs or the projects. So hopefully we answer this question. So we have a couple of more, but we are already running short of time. We are 3 minutes over our stipulated time frame. So we will try to answer the balance of the questions as Phyllis has mentioned that we can follow with you, and hopefully whoever has the balance questions, we have their contact details, and we will try to get back to you as soon as possible. And if somebody has another question as well, just feel free to post these, and we'll try to get back to you with this. So with this, first of all, I would like to thank all of our panelists with all their valuable thoughts and their time. Thank you so much. And thanks to all the attendees, and thanks to the IEEE staff on Smart Grid and education activities, Phyllis, Angie, Emmy, and others. Thank you so much. And I think that's pretty much. And hope to see you maybe in some next event. Thank you very much.
Thank you, everyone.
Okay. Well, thank you to all our panelists, and thank you all for joining us today. If you would like to learn more about this topic, please feel free to explore the IEEE Academies, which were created in partnership with the IEEE Computer Society, IEEE Communications Society, IEEE Educational Activities, IEEE Internet of Things Community, and the Power and Engineering Society, as well as the IEEE Smart Grid Community. Specifically, the IEEE Academy on Distribution Automation offers the latest technical trends and fundamental elements of the existing power generation system that can be applied to the workplace. Please take a look at the links in the resource section for more information on this course program, as well as ways that you can further connect with IEEE educational activities and IEEE Smart Grid. If you would like more information about IEEE Smart Grid and how to get involved, please join the community at smartgrid.ieee.org/join. Finally, as noted earlier, the on-demand link for today's event will be an email to all registrants in approximately 2 hours and will also be available on the IEEE Smart Grid Resource Center. Before you leave, don't forget to complete your feedback survey via the teal survey tool at the bottom of your screen. Have a great day. Thanks for joining us.